Let's try a few example problems here using the super Pythagorean theorem that we just talked about. A sphere is inscribed in a cube. So we have a sphere that's inscribed, perfectly fitting inside a cube. So here's my cube. And within this cube, we have a sphere that's inscribed inside it, which means it's perfectly fitting inside. It's not just inside, it's actually perfectly fitting inside. So staying very snug in there. And so it's kind of like that, right? What is the distance from the center of the sphere? So the center of the sphere is right in the center right there, but that center is also the center of the entire cube too, right? So we have the same center here. From center of the sphere to a vertex of the cube, and we can pick any of the vertices, but I'm going to pick this one here, this vertex. If the radius of the sphere is 2, the radius of this sphere is 2, how does that relate to the outside figure of the cube, right? Right now we're looking at it from an angle, okay? But if we were to look at this directly from the front face, what you would see is just this face right here if we didn't see it from this angle, right? If I redrew this and showed you just this face, you would see this face here. And what you're looking at is you're looking right into this and you would see the sphere sitting perfectly inside it, something like that, okay? And what they're telling you is that the radius of the sphere, this sphere, has a radius of 2. That tells you the length of this face, right? If this is a 2, the entire diameter here is a 4, right? Because that's another 2. But that diameter is the same length as a side of this face. Therefore, that tells us that each length here is a 4 by 4 by 4. Okay? Because it's a perfectly round sphere. All right? So that's what we know so far, and they're asking us to find this length right there. So how do we find that length? Well, one way is to draw a right triangle, as I said before, but I want you guys to try to practice using the super Pythagorean theorem because it's going to make the work a lot easier and a lot faster. And when you do less work, it saves time, but it also prevents you from making additional mistakes, all right? And falling into different trap answers. So here we set up the super Pythagorean theorem once again. We take the 4 squared plus 4 squared plus 4 squared. That would equal the entire length d squared. Be careful, we're looking for half of that. Okay? That's 16 and 16. So we have a 16 times 3 equals d squared. When we square root both sides, what we get here is a d is equal to. Square root of 16 is a 4, and we still have a root 3 inside. Right, so the entire length from here to here is 4 root 3. But if we take the 4 root 3 and we divide it by 2, cut it in half so that we can get this distance, we would get a 2 root 3. And that would actually be our answer. And if this were to be a multiple choice question, that answer might be there. But this one is a grid in. So what do I have to do? I can't grid this in with a square root sign in. I don't have any bubbles for a square root. Okay, so I'm forced to use my calculator and multiply this out. 2 times root 3, which would give me about a 3.464. 464. And so on, right? And I know you have more decimals coming up, but we fit in as many of these boxes as we can. Okay, if we stop at 3.4, that's not correct. Okay, you're going to get that one wrong. If you write 3.5 and round that up, it's still wrong. You have to use all of your boxes whenever you can. Okay, so here what would fit? We would have a 3.46. And that's what we could fit. Okay, that's the only acceptable answer here because if this were 5 or higher, I can round this up to a 7, but this is not 5 or higher. Therefore, I can only round down to 3.46, and that would be the correct answer for this one. Make sure to fill in your bubbles here too. If you don't do that, you will not get credit for this problem. Okay? Let's try another one. A rectangular solid with dimensions 4 by 5 by 7. So we have a rectangular solid. Dimensions 4 by 5 by 7 is inscribed in a sphere. So I'm going to have to, draw into the words there. Hopefully you can still read it. What is the approximate radius of the sphere? The radius of the sphere goes from the center of the sphere, which is also the center of this rectangular box, right? floating inside the sphere. And to find the radius, I just have to come out to any part of the surface of the sphere, which can be right there, right? That point is touching. Therefore, that is the distance that I would be looking for, okay, to find the radius of the sphere. So once again, it's a super Pythagorean theorem problem, right? Again, the first thing I would do is find the entire distance, then cut it in half. To find the entire distance, I have 4 squared plus 5 squared plus 7 squared, right? That would equal d squared, the entire distance. This right here is a 16 plus 25 plus 49. That's d squared, right? That plus that gives me a 41 plus 49 is a total of 90 equals d squared. D therefore equals the square root of 90. And the 90 can actually be broken down, right, to 9 and 10. Right? So square root of 9 is a 3. Square root of 10 still remains. That is d. That is d. We're not looking for the entire distance d. We're looking for half of that, right? So make sure you cut that in half. And that answer should come out to about 4.74. If your answer says 9.49, you forgot to cut that in half. All right, we're looking for this distance, not the entire thing. So A is the correct answer for this problem. Let's try one more. A cube is inscribed in a sphere. So this time we have a cube, which is inscribed inside a sphere, okay? If an edge of the cube is 2, so this is 2, this is 2, this is 2, what is the volume of the sphere? How do you find the volume of a sphere? To find the volume of a sphere, there's a formula for it, and that's 4/3 pi r cubed. To find the volume of the sphere, what you need is the radius. As long as you have that radius, you're in good shape. Okay? So how do I find this radius? Basically, I'm looking for the distance between the center of the sphere, which is also the center of the box, to a surface of the sphere, like we talked about in the previous problem, and we can make that distance there the radius, right? From that center to a vertex of this cube. So we are looking for this distance here. Once we have this distance, that gives us a radius. We can plug it in right there and get my volume, because they're looking for the volume of the sphere. Again, we find the entire distance first, and we do 2 squared plus 2 squared plus 2 squared, and that's d squared, right? So that's a 4, 4, and a 4. So 4 times 3 is d squared. We square root both sides. Square root of 4 is a 2. Root 3 remains, equals d. Now, that's the entire length, right? From that corner to the far corner, that's 2 root 3. So if we cut that in half, divide by 2, right, for half of it, for the radius, we get just root 3. This distance here is root 3 for the radius. Okay, so all I need to do now is to take that radius, put it in there. Volume equals 4/3 pi times r, which is root 3, cubed. So I'm actually going to write that out just so that everyone can understand what I'm trying to do. Root 3 cubed just means root 3 times root 3 times root 3, right? Which is 4 over 3 pi times root 3 is just the 3, right? The square roots cancel out, or you can say that that's the square root of 9, which reduces to 3 anyway. However way you get that, that should be 3. And we still have 1 root 3 remaining. We have a times 3 here, and a divided by 3 here. These guys can cancel out. Okay, there's no precedence here because everything is multiplication. And so what remains is 4 pi root 3. Okay, that would be my volume. And that is the correct answer here. Again, though, we don't have any multiple choice choices, right, to choose from, answers to choose from. So we're going to have to multiply all this out. 4 times pi times root 3. Now, be careful here. Do not use 3.14 to calculate this, because that's an approximation in itself. Be sure to use the pi key on your calculator, okay, so that you don't get the wrong approximation. So you do 4 times pi, use the pi key, times square root of 3. And that should give you about a 21.76. Okay? So can I fit this in the 4 boxes here? No, I have 1, 2, 3, 4, 5 different characters here. So what I'm going to have to do is fit in as much as I can. That would be a 2, 1, point, 21.7. Okay, so 21.7 would be the correct answer. For this one, because that number there is 5 or higher, you can round this up, and your other answer could be 21.8 as well. So if you used an 8 here in place of the 7 and filled that bubble in instead, this would also be a correct answer. So the correct answer to this problem would be either 21.7 or a 21.8.